study that she's been working on, and she'll tell you the details of the shade study, but it's been pretty interesting. A little bit of work, but pretty interesting. Kelly, take it away.
All right, so it's an exciting time to be a grad student, or maybe it's just for me since I'm almost done. And so just on November 3rd, we had our last harvest for our shade study, and I've got most, but not all of the results to kind of share with you. I don't have quite all of our nutritive data or the alkaloid data back yet, but I've got a lot of other things to talk about. And also from previous harvests, I've got all of those as well. So there's been a lot of research within my lifetime, which I know hasn't been that long, about how shade can impact an individual forage species. And that kind of drove how we decided to do our project. But we got to thinking that, you know, our pastures aren't just composed of one species by itself. So we wanted to look at how different mixtures could respond to shade and different levels of shade. And a lot of times, well, all the time in silvopastures, we've got shade that's filtering down through the forest floor at different levels. And one of the big questions is how much shade can plants tolerate, and is too much shade going to reduce their growth, change their nutritive characteristics, and everything like that. So that's kind of the background to why we wanted to get at some of these answers so we can make recommendations to people in Virginia about how these forages can respond to a system that could happen here. So going back on our plant physiology, if you're a little bit rusty, the reason we picked cool season grasses and legumes for our mixtures is because they've got a light saturation point of about 50% of full sunlight. So that means that anything above 50%, they can't increase their photosynthetic rate. That doesn't mean that they stop producing, they just can't make a higher rate of photosynthesis. So compared to warm season grasses who can use up to 85% of the full sunlight, or can keep increasing their rate, they don't quite use as much sunlight as we think of warm season grasses doing. So that's why we picked cool seasons for our plots. Also, it would have been a little bit more difficult to manage for both cool and warm season species in regards to our cutting frequencies. So we just made it simple and did it that way. And so tall fescue is included in all of our mixtures because it's probably the most common pasture grass in Virginia and most of the US, or at least in the southeastern part of the state. And so we all know that there's the endophyte association, which is great for the plant. It gives it a lot of its beneficial agronomic qualities, why we like it, because it's so tolerant and hardy. But it has those pesky alkaloids that are a problem with our cattle. And a very recent estimate from this year is that the cattle industry is losing over $1 billion each year in the United States. So that's a lot. And so anything we can do to help mitigate that is going to be a benefit, not only to the small farm scale, but all the way up to the industry as a whole. So we took a lot of data, like Chris said, it was a lot of work, and to get at how shade impacts all these different characteristics. Now, I mean, yield's a good estimate of forage production, but it doesn't tell you the whole picture. The nutritive characteristics are very important when you're talking about animal performance. You can have a lot of biomass, but if it's really crappy feed, it's not gonna help your cows gain as well as maybe less grass, but better grass. And so we're also gonna quantify the ergot alkaloid concentration, important for the fescue toxicosis issue. And then we also had some sensors set out to monitor the microclimate. Hopefully that's going to give us an idea of what's driving the differences in our yields, in our nutritive characteristics, and things like that. So these are the 3 different mixtures that we planted, differing complexities. So we had just tall fescue and white clover to begin with, kind of maybe our standard Virginia pasture. And then when you go into the intermediate, we added red clover and orchard grass being one of those species that is very, very well adapted to shade. And then in the complex mixture, we added more legumes, alfalfa, bird-soot trefoil, and we added Kentucky bluegrass as well. All of the species had been shown in previous research to look promising to be adapted underneath shade, so that's why we picked all of those. And then we had 3 different shade levels compared to a full sun. what we did is we kind of created a open frame and then laid snow fence on top of it, or you guys probably call it sand fence from Virginia. And so that was our 50% shade structure. And what we did, we took half of those slats out in order to get down to 30%. And then, so those structures are really heavy as it is. So it takes 4 people to move them. And so we didn't want to have to add more wood to get a higher shade level. So that's why we put that shade cloth on, just to keep a little bit, well, because the field crew is already mad at me when we have to move them twice in one day. So we didn't want to make it any heavier. And so on harvest day, we had a lot of stuff to do. We took pictures of plots. I took height readings. I had a rising plate meter, which kind of gives us an idea of how dense the canopy is, because some canopies are tall but sparse, some are short but much denser. But unfortunately, I don't have all that data analyzed today for you guys. But what I can tell you is that the full sun plots were more dense because they had a lot of crabgrass in them. That kind of filled in between where we had seeded our cool season species. So because they had higher density readings, just because they were more filled in than some of the other things. And then we took 3 samples. We had yield, and we had our botanical separations, and then we had 1 sample for alkaloid concentration. And then at every harvest, I also took our temperature and moisture data that had been continuously logging for since the previous harvest, and we'll go through some of that at the end. So what everyone wants to know is, does shade reduce yield? And in our case, it does, but you just got to keep in mind that this is one system throughout the country. Things are going to change based on the species you have. Presence of a tree canopy could change this a lot too, but just purely on shade, we do get a little bit of a reduction once you get up to moderate and heavy shade levels, that 50 and 70%. But that 30%, I mean, that's light shade, no reduction. It's even a slight increase, not significant. But so that's really good to know. If you have a young silvopasture, if you planted it, or if you did a really, really heavy thinning, you should be able to get just as good a yields as you would in an open pasture. So it probably wouldn't change management too much. Some of the nutritive characteristics definitely changed. Neutral detergent fiber, we tend to want this to be a low number. That means better quality usually. And so this data is only up to June of 2016. We had a harvest in August and in November. So this is mostly kind of springtime data, except for August of 2015, the second bars. But what it looks like in the spring is that shade kind of increases that fiber component. And one reason this could be happening is because when our plants get shaded, they want to grow taller. They want to grow out of their shade. They think that they can kind of outcompete the things that are growing around it. They don't really know that the trees are too tall to grow beyond. So they need extra structural components in order to support increased height. Otherwise, they just topple over. So they're going to be putting more fiber into their cell walls to keep them up straight. But then, of course, in the summertime, we get a little bit of confusion and there's no increase there. So it's going to take a little bit of teasing out of data. But generally, it looks like that we're getting just a little bit worse quality. I don't want to quite say that. But for fiber components, it's going to increase just a little bit when you get shade. When you have crude protein, there's requirements that each kind of class of livestock has in order to maintain its growth and, I guess, maintenance requirements. And so this is just for the first year. And we had all of our plots being able to meet or exceed dry cows, lactating cows, and growing steers' crude protein requirements. And in the springtime, there's kind of no difference. All of the shade plots and the sun plots, they all had about the same amount of crude protein. But then in the summertime, when it gets real hot out, the shade plots had better crude protein than the full sun. And a lot of other research has kind of showed a similar characteristic that shade increases crude protein. So even though we may not be getting as much yield in those high shade plots, they're still producing a little bit better quality forage in regards to crude protein. And then here in 2016, we had some interactions going on that don't make nice graphs, but what this is kind of showing is that there is no relation for the simple and complex mixtures in regards to crude protein. That's why they don't have a line connecting them. But that intermediate mixture, for whatever reason, had a little bit of a peak with crude protein underneath that 30% shade, and then it dropped off a little bit. Once again, hard to understand. I don't know if I understand it, but just another piece of the puzzle. When we go to TDN, total digestible nutrients, this is calculated, or I calculated it, in relation to another fiber component. But it's kind of a measure of how many nutrients or how much energy that animals can get from a feed source. And so in the springtime, we can support dry cows and lactating cows, but the growing steers may need a little bit of an energy supplement for these plots in this particular area. Except in the sun plots, those are growing pretty well for everybody. When you get a little bit of shade, then it drops off a bit. And then in August, we see an increase in total digestible nutrients. So there's a relationship going on between probably climate and how these plants are responding to shade. Another kind of confusing graph, just showing that in general, for 2016, we did get a reduction in shade, and this is for April, May, and June. So this doesn't have our summer results on it yet. So this kind of follows a similar pattern to what we saw in 2015. So as I mentioned, I think there's an interaction going on between the climate. So in the springtime, we saw a little bit of reduction in quality parameters underneath shade, but then in the summer, our shade plots had increased crude protein, and I think we're gonna see that once I get the results back for our August harvest this year. So I think that having the shade on the plants is a benefit to their quality, even though we may be getting a yield reduction. But maybe that 30% shade is the sweet spot. You don't have to get a yield reduction, you might get better quality. And so we took a sample and separated each of our species so we knew how much tall fescue was in each plot or how much weeds and things like that. So this is just the simple mixture, only tall fescue, white clover. And we had really good tall fescue yields underneath shade. So it being a cool season grass, it responded to having a little bit of shade. And if you look, so this is only in the springtime, and I'm gonna show you summertime data because we get some differences. But white clover did really well in the full sun plots, and it just didn't like the shade. We got less than 10%. So that's one plant that, at least for our area, didn't do as well as we thought it might. And then, of course, weeds increased underneath shade. And what kind of happened was, as the white clover dropped, the weeds replaced it. So kind of a ecology lesson is that when you take out something that's fulfilling a role, you're gonna get it replaced with something else. So we didn't just have bare ground, we had weeds come in. And then in the summer, what we had was a lot of crabgrass came in, so that's the purple line. But then once we get some shade coming on, the tall fescue really increased, but of course the white clover dropped again. So the intermediate mixture, we had orchard grass and red clover doing pretty well. Orchard grass is that orange line, and red clover is the green. Weeds were kind of a problem again, but we're gonna have that. And this is 2016, where I didn't show 2015 because there's just a lot of weeds throughout the whole plot, so I didn't wanna mess with that. But orchard grass, if you think of the name, orchard grass, it's kind of adapted to growing underneath a partially shaded condition, so it's doing really well. And we don't see a lot of it in this part of the world. It's pretty hot. So having that little bit of shade, especially in the summer, which we'll see, it really helps it to grow better and then sometimes tall fescue and other plants. So this is the complex mixture. We had added bird's foot trefoil, Kentucky bluegrass, and alfalfa as compared to the previous mixture, but the bird's foot at the end of our harvest was completely gone. I didn't find any of it in November. And Kentucky bluegrass really didn't appear much throughout any of the harvests. So I just kind of left them off the graph. It would have been a little bit more cluttered. But orchard grass is just doing so well. So if anyone wants to plant a silvopasture, I would highly recommend orchard grass. And then in the summer, for whatever reason, I don't know why, the red clover, which is the green line, did really well underneath those low levels of shade. So that's another plant that I would definitely recommend. Although at the end of our harvest, there wasn't a lot of red clover in November, but it had been planted for 2 years and it's kind of a biennial species, so it would probably need to be reseeded, but it does add a lot of biomass to these plots, especially under shade. So here's the alkaloid data, and keep in mind the yellow bar, the simple, we had a higher proportion of tall fescue because it was only a 2-species mixture. And that's why we're getting such increases as compared to the simple and intermediate mixtures, because those kind of had other species to dilute those alkaloids. In the simple mixture, we had around 50 to 70% tall fescue, and in the complex mixtures, it ended up being around 15 to 20%. So that's really the driving factor of why we saw a reduction in alkaloids in more diverse plots. There was 2 instances where we kind of had interactions where each of those mixtures kind of acted differently in response to shade. And really it was the simple mixture that had more tall fescue in it that was driving it. So August 15 and June 2016, which was at the end of June, so it was already getting pretty hot. Sometimes in the hottest parts of the summer, we did see a very slight increase of alkaloids underneath shade. And once I get the August data from this year, I might be able to add on to this, and if it acts the same way, then we might want to think about offering other strategies to mitigate higher alkaloid production underneath shade. But since we don't have all the data in, I can't quite make that claim yet. And so some of the things that might have been driving our production underneath shade was the temperature. And so we had soil probes buried 2 inches below the surface for soil temperature. So it's still in the root zone, but close enough to be able to monitor some fluctuations. And so this was in July of this year, so it was already pretty hot. And what I should have done was shown some August data, because we were getting 10-degree differences between the full sun and all the shade plots. But so each of these peaks are the peak of the day, sometime in the afternoon. And we can see that we're getting about 5-degree increases just in July. So at night when the temperatures cool down, they all kind of equilibrate to something pretty similar. But then, of course, in the next day, they're going to be extra hot underneath the soil surface. And cool season grasses and legumes have an optimum temperature of how they like to grow. Usually it's 60 to 80 Fahrenheit of above ground temperature, but that also has to translate into below ground, because the hotter it is, the more their roots are going to restart and the more energy they burn up and can't use for growth. So this could have been part of the factors driving some of our results. And the interesting one is soil moisture. These were buried 4 inches below the surface, so still in the root zone. The blue line is the full sun, and each of those peaks was a rain event. So we can see that when the plots are drying off, the full sun ones are drying out a lot more than the shaded plots. And it doesn't really look like there's much of a difference between 30, 50, or 70% shade. Just as long as there's some shade on it, it's able to hold more moisture in the soil. And so kind of to wrap things up, we had a little bit of a yield reduction based on shade, but I didn't show any graph how mixture affected yield, because it didn't. So that was kind of a little bit surprising to me. We like to think that more species diversity results in higher yield, but we didn't see that here. We had differences in nutrient composition throughout season and throughout shade. So that's just one thing that we need to think about. Test your forages. We like to say that. So knowing what you have and how the shade can impact it is going to definitely impact management decisions and whether you need to supplement or not. The alkaloids in general, most of the time, especially in the spring, there was no difference underneath shade. So that was really good to know. We really wouldn't want to see extreme increases because that could lead to more problems. But we had a bunch of factors that were all working together to affect these different characteristics, and it's impossible to measure all of them. We could have had real trees instead of shade structures that would have affected water in the soil. We could have had wind sensors and all this other parameters, but in general, we kind of got a cool snapshot of what you could have in Virginia. And if anybody has any questions, I guess I'll answer them now.
Yep.
Right?
We've got 15 minutes on the schedule for discussion now, and go ahead. No.
Kelly, a couple of pushbacks we get on silvopasture are the use of non-native forage species. Just from a plant diversity standpoint and also from wildlife habitat, there's an impression that native plants make better wildlife habitat than introduced plants. Any comment on that, and are there some native cool season choices?
I don't know about native cool season choices. I haven't been doing any research on that. But what I had been looking at was how species diversity can affect yield, since that's kind of a big component of my research. And one thing I was seeing was that up to a certain point, sometimes adding more species doesn't really benefit a plot, but on a yield basis. But what I had been seeing was that it all depends on species selection for the area. If you choose species that aren't adapted, I'm trying to think of a good example, some species that are maybe more cold hardy than, or they wouldn't be as heat tolerant, those maybe wouldn't do so well here. But there's honestly a reason we've chosen agronomic crops, is because we've made them high yielding, whereas a lot of the native species haven't been improved as much to increase the yield. So that's why we did all of these agronomic varieties. But you definitely could use native species. But I don't know any that we would recommend.
John, where's John at? Do you have any comments on native warm season grasses? And I've thought about that too.
There's some variation in like the native warm season grasses, switchgrass. There are some lines that have greater shade tolerance than other. They are warm season grasses, so we think of them as being more productive in environments where there's greater amount of light and more heat. And so if that's what you're after, then maybe that means you gotta have fewer trees. And probably, you think about kind of those pine savannas that you mentioned earlier, you have to think about, more broadly distributed with those warm season components. So, I mean, those are the trade-offs you're working against, right?
Are there any native cool season grasses and legumes that we can?
Well, so there's a lot of, I would say there are a lot of native legumes. And if you go look in a pine plantation, early stages, you're probably going to find a bunch of those. They're not necessarily the most productive. Some of the tick trefoils and, I can't think of the genus now, that the tick trefoils and the desmodiums, thank you. A lot of those are out there, and they're putting little bits and pieces of nitrogen back into the system for you, because nobody's, typically, those trees go in the ground and nobody's doing anything to fertilize them, right? And so those native legumes that can tolerate that, low soil pH perhaps, or those kinds of environments will come on. And in fact, in some of our black walnut stands back in Blacksburg, we see some of those desmodiums come in. Cool season grasses, probably not as much.
How about Virginia wild rye?
You'll see some Virginia wild rye, but from the standpoint of persistence and productivity, you're not going to get what you want, I think, in a pasture system. So, the old saying about having your cake and eating it too, which always seems kind of disappointing to me. Why would I want cake if I can't eat it? But you got to figure out what those trade-offs are, and I appreciate the desire to have natives. But wildlife like habitat, there are benefits to having good habitat as well as it's not all necessarily related to feed issues. Yeah, we have a guy in Halifax County who has twin rosettes of pine, loblolly pine, 60-foot alleys, I think. Some he's got in fescue, some alleys in fescue, some alleys in mixture of lespedeza and switchgrass. and that he uses it for his livestock, but the livestock go out in springtime when it's for hunting purposes, or not for hunting at that time, but to allow the wildlife access to utilize some of that. So he's managing, or his people are managing for all of those components. And maybe Jason Fisher's around here somewhere. Maybe Jason can talk about that a little bit more. I don't know how much you've seen or watched what Edmonds is doing for that.
You pretty much said his goal is wildlife, and that's what it boils down to. But he mob raises it, cuts it for hay in the spring, and then pretty much the first of August through the end of March, it's for wildlife. Depends on your goals. It does well with it.
It's important to consider what your end goal is, and no two people are going to have exactly the same set of end goals. So if it's wildlife habitat and you're interested in quail, maybe you put in warm season grasses in a silvopasture versus a cool season grass mixture to get to that end goal. If your end goal is livestock production, then maybe you put in a mixture of improved cool season grasses and legumes in a silvopasture.
Yeah, and you're probably not going to put the trees in as densely either. I mean, what he's interesting. I mean, to have that kind of double row set is actually fairly high density in terms of numbers of trees in that system. But it works for him. But if your goal again, like quail or something like that, you may want to change that structure a bit, planting density. What do you need on the economic return down the road?
Definitely.
I realize it would probably depend on like your basal area and your general overall, how large your system was. What do you think would be the potential, like especially maybe more here in as you get into the southeast and all where it tends to be warmer, like having in the more shady areas like the orchard grass or more cool season mixture, and then in the areas that would be more typically sunny, like either warm season native or even like Bermuda grass or crabgrass or something.
I think that's a good idea, because I was just thinking about a month or so ago, we want shade in order to provide a cooler climate or a more comfortable climate for the cattle in the summer. So wouldn't we want to have our most forage growth underneath that shade in the summertime? So warm season grasses, they're going to have more forage growth during that time than the cool seasons would. So I think it's a good compromise to, like you said, have maybe a system that's going to grow the warm season grasses better, maybe have a little bit less shade. I think it's a good idea to kind of diversify that in order to keep your forage growth throughout the summer, rather than just having a nice dense shade where maybe you're not going to get your peak forage growth when the cows need the shade the most.
For establishing the grasses and like an existing stand of trees, is it just broadcasting and letting it go? Or is there some type of corporation,
We're going to talk more about that later on today, but generally speaking, you're going to have better success with forage establishment in general if you get good soil-to-seed contact, and that's going to require some type of seed bed preparation, and then some type of improved seeding method rather than just broadcasting that seed on top of the soil. And we're going to look at what we did out in our silvopasture demonstration this afternoon. But we did do seed bed preparation, and we did use an improved seeding method on that to help get a better stand of grass underneath there. And you can throw seed out, and if all the stars line up and you put enough money in the plate at church, you can get a stand that way in some cases. But you're opening yourself up to risk if you don't have good seeding practices.
I would say generally we would probably use higher rates.
Yeah.
And Chris is kind of looking at me because I did it was called a Thanksgiving planting, I think, and not something you would recommend. But I did do a broadcast seeding at that Shenandoah Valley, and we have seen some issues with soil fertility. If you're coming back into some of the sites like what would be down here, it probably would be hard to get much of a stand with broadcast seeding, particularly in terms of the nutrient issues and that sort of thing. There are different tricks for how you might manage that if broadcasting is the only way you can do it. But seedbed prep, if you could do it, that would be preferred.
My old forage professor at Ohio State, Paul Henderlong, used to say that you can't compensate by increasing seeding rate for a poorly prepared seed bed, and I think there's a lot of truth in that. So we could throw as much seed as we want on the floor in here, but we're not going to get a stand of forage. And you know, if it's a kind of a moderate seed bed, maybe increasing seeding rate will help some. Emily?
You're gonna talk about this later as well, we can wait till then, but, I mean, did you have to do a lot of either herbicides or some other type of treatment to combat if there was volunteer woody growth coming back up?
So the question was woody growth, and maybe that's something we can discuss out in the field. In our Silvopasture project, I'll tell you what we put in for woody growth, and was goats, and using those within that system to help combat that tree sprouts from hardwoods, especially. But you are going to have hardwood sprouts. You know, even in a heavy pine stand, the first succession in there is going to be sweet gum trees, and somehow you're going to have to manage those, whether it's with a herbicide or whether it's with livestock grazing or clipping. You're going to have to manage that hardwood sprouts.
Kelly, very nice. Great to see you brought down your Wisconsin.
Yeah.
When you showed the dry matter yield in the beginning, was that average over all of the harvesting?
It was, because I just analyzed it a few days ago, and I didn't have any year by treatment interaction, so I was able to just lump it all together. And I could show the differences between spring and summer, but statistically, the computer said I didn't need to. So
You had 4 harvests per year?
we had 2 in 2015. We didn't want to cut too frequently, so we could, let the forages have enough time to regrow and get a good root system established. And then this year we had 5. We had April, May, June, August, and November.
Can you just talk about how you staged your harvest based on height?
Oh, we had a target cutting height. The proposal said 10 to 12 inches, and when I took our pasture readings, it was almost always around 14 to 15 inches. So we had a pretty stable, we should have been pretty uniform in the results we had. But once in a while, the grasses just didn't quite seem to get as tall, but they got a little bit more mature. We had one harvest, and I can't remember which one it was, that our alfalfa was blooming more than it had previously. So there was a couple times where the maturity got ahead of us, even though they just didn't get quite as tall. But for the majority, especially during the springtime, they were all fairly vegetative. No seed heads were present on our grasses, and the clovers and stuff hadn't flowered yet when we cut.
We're really trying to manage them like you would manage in a grazing system. It's not the same, but kind of simulating that lower height, so we didn't let it get 3 foot tall in the spring before we took that first harvest.
Could I just ask further that, comment further perhaps, you had good response with the orchard grass?
Oh, yeah.
I suspect that, if we had ruminant animals in there, they put a lot of pressure on that orchard grass, whether it really persists.
Right, and I mean, that's the hard thing with research. I can only do so much, So this was kind of just to get an idea of how our different mixtures are going to respond to shade, but definitely having animal pressure, they're not going to graze evenly like our forage harvester did. They're going to pick and choose. Things are going to get grazed taller or shorter based on their preferences and the time of year. So yeah, it's just another variable that we have to think about.
So one thing, if you take one thing home from today's training today, is that silvopastures have to have managed grazing underneath them. That's really, really important. We just can't make a silvopasture and put all those animals in for 3 or 4 months in the summertime. We've got to have rotational stocking to maintain those stands of improved forages.
Could I just say that unless you have anti-impact control testing,
Oh, yeah.
right? Because in essence, that's what, John, you were talking about, that you just leave the tall fescue go. I mean, that's what persists. And I'm maybe making a little bit light of it, but I mean, that actually the tall fescue is a strong component. And it's interesting to see that your data showed that adding diversity didn't really help dry matter production. And that didn't necessarily help quality so much, perhaps. And of course, the alkaloid
Yeah. What we did see, oh shoot, I lost my train of thought.
I think the, the alkaloid data may slip past some of you, but the impact of mixture on alkaloid data was pretty dramatic. And that's pretty important. If you're using hot fescue in a system or infectitol fescue, getting more diversity in there really did have a significant impact on alkaloid concentration in those. And we were way above in the simple mixture, we were way above the threshold for seeing negative impact on the animal.
But it got it back where you were close to being below that threshold.
Yes,
too.
it did with increasing the diversity in those mixtures.
And then that's not taking in the component that they just talked about, the selective grazing of the cattle not eating the fescue in that mixture. So it would actually be lower.
Yeah.
To the cattle.
Yeah, so Taylor's remark is that there's going to be, whenever you have a mixed stand of forage, there's going to be selectivity by that animal within that stand of forage. So it's actually going to be selecting against the fescue most likely because it's making the animal feel bad in the summertime especially.
And I'll say that, when we think about potentially using a forage type like the hot fescue can endure more continuous grazing, in this system, managing the livestock is equally as important to the health of the trees. Okay, we got those three components: the livestock, the forages, and the trees. So I'll go back to Chris's point that he really drove home. We've got to manage those animals and rotate them through that system to have a healthy overall system. Tom, I want to ask, you said you often get pushback using non-native species in silvopasture. Who's that pushback coming from?
Well, it's mostly in native hardwood stands, and the idea that we're starting with in some cases, a relatively natural, I won't say pristine, but a natural plant community, and then introducing these non-native forages. The project in Missouri, the Werdock Farm that University of Missouri established, their Fish and Game state agency objected to the whole idea because they're saying you're taking a native plant understory and replacing those understory native plants with, I think it was, I don't think they used tall fest, I think they did. Oh, they did?
There's
Okay.
an article actually about the lack of dialogue between the university and the natural resource community, and sort of where NRCS was kind of in the middle of this whole thing. And it's pretty interesting, but yes, go ahead, sorry.
Yeah, so that's where that.
So it's really coming from the wildlife community.
I think that's
Yeah.
just conservation, right?
Yeah, native plants folks also. Yeah.
And honestly, if they had talked with each other,
Yeah.
they probably could have resolved it, because they could have put some switchgrass or some other materials in that system to deal with that.
Can I follow up on that?
Sure.
The point of having dialogue is important. It's great to see a mix of people in this room. The other thing is that sometimes producers will be looking at a woodlot as, that's my next pasture, completely removing all of that woody biomass. And so leaving some, even if it's with hot fescue underneath, is better because you at least have some vertical structure, some biomass and stuff like that there.
Yeah, and
I will
John, go
follow one more comment on that. I think it's one of the challenges that I see, and Adam and I have a lot of work together. It's interesting working with Adam because we'll go into a silvopasture and he'll look at the forages and say, is this all right? What's going on here? And I'll go in and I'll be looking at trees. What should we be doing with these trees here, Adam? And from my perspective, and Adam may have a very different one, I'm sure he does, but from my perspective, getting it right so that the trees are more than just a shapes component will be important.
Yeah.
But even if that's all it is, that's not necessarily the worst of all outcomes when you look at what it means in terms of animal comfort, animal productivity, animal welfare, buffering the system against climatic extremes, and potential to, maybe mitigate environmental issues relative to runoff or that sort of thing. So, I'm not not exactly sure how far we go on the spectrum of what's good or what's bad, but I mean, I think there's opportunity that will be harder to capitalize on getting good out of the trees, but that's my end goal, is to try to get there. The lower hanging fruit is kind of dealing with these sort of animal and environmental or nutritional issues.
All right, so it's time for a break. I'll say one thing before the break, and we talk about animal productivity, but as we move forward and there's more eyes on agriculture, you know, animal welfare is becoming a greater issue. And if PETA ever found out that our animals are suffering on tall fescue, you know, we need to be aware of the animal welfare issue as we move forward. And Gabe is going to talk about the impact of shade on animal production in silvopastures after the break. So we've got a half an hour.